In earlier lessons, we learned about high bandwidth challenges related to deploying 5G networks in the future. What are the service scenarios with high bandwidth? The first thing that comes to mind is HD video. At present, video technology is evolving from HD to 4K to 8K UHD display. Focusing on the development of the UHD video industry can better accommodate people's upscaling needs for cultural consumption, as well as promote the overall upgrade of the information industry. Users can gain access to a much better viewing experience as a result of 4K and 8K videos' much higher image resolution. In the future video entertainment market, UHD video will be mainstream. How large is the bandwidth required by 4K and 8K videos? Take UHD 4K display as an example. The video resolution is 4096 by 2160 pixels, with 120 frames per second. Each pixel consists of 3 signals, red, green, and blue, each carried on 12 bits. In such a case, the 4K video needs 4096 by 2160 by 120 by 3 by 12 bits every second. After H265 compression, the required network bandwidth is about 50 megabits per second. As such, the bandwidth required for 8K videos reaches 100 megabits per second. VR is a computer-generated experience taking place within a simulated 3D world. It allows users to have visual, auditory, tactile, and other sensory feedback. In this immersive environment, users can observe things in real time in the 3D space without restrictions. Entertainment, education, and healthcare will be the 3 major applications of VR in the future. Terminal devices, such as VR helmets and gloves, generate realistic sounds, images, and tactile sensations that simulate a user's presence in an imaginary environment. After the device is switched on, users can feel that they are in a completely different world. For example, users watching a basketball game can feel that they are physically present at the stadium because of the cheers and other sensations that can be experienced through VR devices. Cloud VR intends to make VR devices more simple and cost-effective. Contents of videos, games, etc., and post-processing are moved upward to the cloud. Physical devices are only used for video rendering and visual and tactile restoration. Therefore, a large amount of data needs to be transmitted between terminals and the cloud. Traditional VR terminals are dependent on wired networks, with limited mobility scope. Mobile VR enables users to access VR services anytime and anywhere through wireless networks. VR application scenarios can be greatly extended, imposing higher bandwidth demand on networks. AR applies computer-generated perceptual information to the real world, having virtual objects seamlessly interwoven with the physical world. In the future, AR will be widely used in telemedicine, real estate, advertising, and other industries. AR combines the sensory information with reality and achieves superior interaction. For example, the holographic glasses, Microsoft HoloLens, released by Microsoft, can project news information flows, provide videos and weather reports, assist 3D modeling, simulate scenarios for Mars landing, and offer simulation games. To enable better sensory perception in services, a network requirement of both VR and AR services is high bandwidth. How much bandwidth is required? Take the VR video in ideal state as an example. The panoramic video is 16K by 4K, 60 frames per second. Each pixel consists of 3 signals, red, green, and yellow. Each is carried out on 10 bits. In this case, VR video requires 15,360 by 3,840 by 60 by 3 by 10 bits per second. If the encoding format is H.265 with the compression ratio as 1 to 40, the required network bandwidth is about 2 gigabits per second. The world is large and varied. Most people want to travel and view magnificent landscapes, but are constrained by time, budget, and various other reasons. If we did manage to go traveling, what would be the best way to talk face-to-face with our families at home? 3D holographic virtual technology will soon enter our lives, and we will be able to feast our eyes on world-famous sceneries whilst sitting at home. Irrespective of location, you can communicate with friends and relatives as if you were sitting together. 3D holographic projection records and redisplays objects by using interference and diffraction principles. It is a 3D technology that allows viewers to see stereoscopic virtual characters without wearing glasses. The technology is used for different things such as product exhibitions, automobile launches, clothing release press conferences, stage performances, interaction, bar entertainment, and interactive projections. 360-degree holographic projection is a real 3D hologram, equipped with 360-degree phantom imaging. However, this kind of projection requires higher network bandwidth. MirrorSys is like a super home theater. It features a 220-inch seamless screen, ultra-wide 110-degree horizontal view, UHD 8K image, and a 22.2 multi-channel sound system, providing users with an immersive and interactive experience. Ultra-large screens, ultra-large views, and Ultra HD images require ultra-high-speed networks. It therefore can be seen that the ultra-high-speed network is crucial to the wider application of immersive media. The preceding analysis of VR and AR services, such as 4K and 8K UHD videos, proves that high bandwidth is the key to supporting such services. Can our existing LTE networks efficiently support these high bandwidth services? The theoretical peak rate of a single LTE cell is 100 to 150 megabits per second, and the average data rate is about 30 to 50 megabits per second. Obviously, the LTE network fails to support UHD videos and VR services. As services continue to develop, network capacity is increasing, and in particular, unlimited packages emerge. The minute of usage, or MOU, increases rapidly, doubles each year. A consequent result is that the 4G bandwidth in many places is insufficient. Many users may have encountered this. Videos always pause for loading at tourist attractions during holidays, at railway stations during the Spring Festival, or at congested high-speed intersections and large gatherings. Why does this occur? It is very simple. In the preceding scenarios, there are a large number of users, each holding a phone in their hands. With so many people accessing the internet at the same time, traffic congestion is bound to occur. That's why we have to constantly improve network capacity. 5G uses new radio access technologies to improve spectral efficiency. Adding larger carrier bandwidth, the peak data rate in the future can reach 10 gigabits per second, 100 times higher than that of LTE. With 5G, the data rate of network connectivity is greatly improved to better support high bandwidth services, such as 4K, 8K UHD videos, and VR/AR entertainment. This lesson has described some of the main 5G high bandwidth service scenarios, such as 4K or 8K UHD videos, AR, VR, 3D holographic, and MirrorSys services. These types of service scenarios offer users better experience, but require higher bandwidth on the network. The existing LTE network cannot meet the requirements, so we have to look to 5G networks.